Hello everyone, welcome to the video series of NAT configuration on Checkpoint Firewall. I hope you have seen last two videos. Therein we discussed some basic concepts, how we can implement source NAT and destination NAT. So in this video we will see some advanced concepts related to NAT. Let's see what exactly is the task for this video. So it says for this task remove default route from R1 and R2. Okay, and then configure NAT so that R1 loopback should be able to access R2 loopback. So it looks simple. So we need to first remove the routes and then we need to simply access R2 loopback from R1 loopback. Okay, go to that test machine. Oh, okay, let me see my VPN connection. VPN is up. Then let me try again. Okay, let me log into. I hope no one has booked a slot on this time. Okay, perfect. Okay, so go to R1 and configuration mode, delete protocol static route 0.0.0.0 and then commit and then go to R2 as well, delete protocol static route. I feel somebody has slot at this time, so that is the reason I'm getting frequent disconnect. Give me a second, let me see who is doing lab. Okay, someone was using the lab. Now we should not see more disconnection. So we were discussing first routing has to be removed. So R1 we do not have any default route, and if you go to R2 again we do not have any route. So task says, let me go back and read the task. Now task says R1 loopback should be able to access R2 loopback, but now if we do not have a route, I cannot simply go ahead and write 160.1.1 interface 150.1.1.1. So we cannot do that because there is no route. Now this R1 can only reach, or let me go to R1. So now this R1 can only reach these subnets 136.1.1.21, 150.1.1.0 and 192.168.70.0. So we cannot initiate traffic directly on R2 loopback. We have to initiate traffic on some IP address which is local to R1, and that is, I believe, 136.1.1.21. That's the best IP address here. So now what we can do is we can initiate traffic on firewall internal interface, for example 136.1, or let's take basically virtual IP address. I'll update the task here which virtual IP address you need to take here in task 5. So go ahead and create a policy first. Policy, for example, says there is so much traffic on cleanup rule. Okay, so R1 to R2. So R1 here is 150.1.1.1. I will use the same subnet here. Perfect. Destination IP address can never be direct 160.1.1.1 subnet IP address. So it should be something NAT-136.1.121, and you can use 102. So I will suggest to use 202, for example. So I'll update that in task. So you have to use this IP address, not the other IP address. Otherwise there will be a clash of IP addresses in the lab. So 136.1.121.202. Perfect. So we will initiate traffic on this IP address. Whatever services are required you can mention here. I'm good with telnet and ICMP, for example. And then action accept, logging enabled. Perfect. Go to NAT rule. Source will be 150.1.1.1.1. Traffic will come on this NAT address, which is 202. Now, destination we have to translate, that's for sure. For example, do we have specific object for 160? No, we do not have. So click on node host r2-160.1.1.1 and 160.1.1.1. Perfect. So we have object there. So we have translated destination IP address. Now we need to translate the source IP address as well. Why? Because this R2 also does not have any route. So R2 doesn't know how to reach, again response, how to reach back to 150 address. So this R2 can talk to only 136.1.1.2 network. So what we can do is right click, add hide new node host fw-136.1.1.2.102. That's the firewall interface address. We can do source net from this IP address. Perfect. 136.1.1.2.102. Now we have security policy, NAT rule in place. I want to add a proxy ARP. So this time let's add a proxy ARP from CLI. Add proc, not add ARP, and then proxy ARP, and then IP version 4, for which we have to add, that is 136.1.1.2.1. I believe we did use 202. Let me verify again. 136.1.1.2.1.202. Perfect. 136.1.1.2.1.202, and then interface. This time it is Ethernet 1. Perfect. Save config. Push changes. And next is test. If security policy, proxy ARP and NAT rule is okay, we should be able to see response back from R2 loopback. But we will initiate traffic on 136.1.1.21.202 address. 202 address. Perfect. Okay. Let's wait, and then we can test how does it work. Okay, almost done. Sorry. Okay, so I'm on R1 now. I will do a ping on 136.1.1.2.1.202, and source interface we can force as 150.1.1.1. Awesome. So I can ping 136.1.1.2.1.202 from this loopback, and if you go back to tracker, verify the logs, we should see source and destination both are now getting translated. So source is 150.1.1.1, destination is 136.1.1.20.1.202, and source is being translated with the firewall interface IP address, and destination is 160. So effectively we are getting response back from 160 address, which is R2 loopback. Okay, let's move to next task. Make sure no routing exists on both routers. Okay. Configure a new loopback on R2 using IP address this. So let's do it one by one. So routing, definitely it is not there because we did remove in task 5. And now task says to create a loopback on R2. Okay, R2, go to configuration. Right now run show interface. If you do, we have just one loopback. Set interface loopback 0 address 150.1.1.1.5. Someone was saying in last class multiple IP addresses are not allowed on loopback, so you can see it can be done. So I'm creating a new loopback basically, and on the same interface which is loopback 0. Let me do a commit and run show interface. So I have 160 as well as 150.1.1.5. Perfect. Now it says create appropriate security policy and do other changes if required. Okay. Configure NAT so that R1 loopback should be able to access newly created loopback on R2. So that's the example of overlapping networks. So R1, let me show you how it is overlapping. So R1 also has show interfaces 150.1.1.1.1/24. So if I'll do a ping on 150.1.1.5 from this R1, this traffic will never reach to router, because router will treat this as a part of local subnet, and there will be R broadcast, and locally router will try to identify that IP address, so it will never reach to R2. And let's see how we can implement overlapping networks. Concept is very much similar to the last task which we have done. Now, and one more change is required. So let's see what that change is. Security policy. Again, I will update IP addresses here. What all IP addresses you have to use. So I will update in task 5 and 6. So create another rule. Name the rule as overlapping networks. Source is 150.1.1.0 and new object I will create, and that is 136.1.1.2.0.2 we did use. Here I will use 203. So 136.1.1.2.0.3. Perfect. Awesome. So we have source, we have destination. I have these two services again. Copy and logging enabled. Go to NAT rule. NAT rule is source will remain same. Destination will be newly created virtual IP 203. Done, and then source has to be translated because there is no routing. So let me do source and again with the firewall interface, and then destination should be 160.1.1.1. No, sorry, not 160. Destination is R2-150.1.1.5. Perfect. Okay. Awesome. So we have 150.1.1.0 traffic will be initiated on 203 IP address. Source will be translated with this 202, which is the firewall interface, and destination NAT will be done with 150.1.1.5. That's very much similar to the last task. Now, what extra change we need to do to make this working? If you go to topology, and in topology, if you see the Ethernet 1 interface, so this interface says complete 150 network is behind Ethernet 1. And now in the firewall configuration, we are doing a change which says 203 IP address has to be NATed with 150.1.1.5 IP address. So there will be a conflict. So let's see how that conflict is there. So topology says 150.1.1.0 is behind Ethernet 1. Now traffic will come on firewall on 203 NATed address. That address will do a NAT with 150.1.1.5. Firewall will do a lookup and firewall will try to send the traffic back via Ethernet 1. So I need to add a static route towards this interface Ethernet 2, and then we need to update the topology as well so that this connection should work. So for that, what I'll do is go to firewall, set static route 150.1.1.5/32. Next hop gateway address, and that address is 136.1.122.12, and then on. Save config. Go to dashboard again. Okay, so go to groups. We have already this group, and in this group I need to add that 150.1.1.1.5 object, so that when response comes, firewall should be able to identify that traffic is behind this interface. Perfect. Okay. 203, we need to add a proxy ARP as well. This time for 203. Awesome. And then save config. Done. Policy push. And let's see how it goes. So you need to do a focus here. Security policy, NAT policy, and then to avoid the address spoofing conflict, I have to add a /32 route towards Ethernet 2, and then I need to update the topology as well, which I did by adding an IP address in the group. Then we added proxy ARP for this 203 IP address, and if I feel everything is in place, so I should be able to reach 150.1.1.5 from R1 loopback once that policy is pushed. Let's wait. Okay, back to R1 for testing. So ping 136.1.121.203, the interface 150.1.1.1. So it will do a destination NAT, source NAT, proxy ARP, address spoofing, all set, and I'm able to ping. And if you go to tracker, we should be able to see that in the logs as well. 150, 136.1.121.203, source is being translated with 136.1.122.102, which is firewall interface IP address, and then we have translated destination, which is 150.1.1.5. Perfect. So that's all for this video. Thank you very much for watching this video series from Troika System. Let's see what is there in the next two videos. Thanks.